Every time you tap an app, send a message, or load a game, your phone's CPU is doing the exact same three-step job, and it's doing it billions of times every single second. Get an instruction. Figure out what it means. Carry it out. That's it. That's the entire CPU in 3 words. By the end of this lesson, you'll know exactly how that cycle works and why examiners love asking about it. The CPU, the central processing unit, is the brain of your computer. It's a tiny chip, smaller than your fingernail, packed with billions of transistors. But everything it does, no matter how complicated it looks on your screen, breaks down into one repeating loop called fetch, decode, execute. Let's walk through each stage. Stage 1, fetch. The control unit goes to RAM, the computer's short-term memory, and pulls out the next instruction in line. It knows exactly where to look because it keeps track using something called the program counter. Think of it as the CPU's bookmark. It always knows which page it's on. Stage 2, decode. Now the control unit has the instruction, but it's just raw binary, ones and zeros. Decoding is where the control unit reads that binary and figures out what it actually means. What operation is this? Add 2 numbers, compare 2 values, jump somewhere else in the program, and which pieces of data, which operands does it need? Stage 3, execute. Now the CPU knows what to do and has everything it needs, so the ALU, the arithmetic logic unit, actually carries it out. If it's a calculation, the ALU does the math. The result gets written back into a register, one of those ultra-fast storage slots right inside the CPU. And then, the whole cycle starts again. For the next instruction, billions of times, every second. Here's where exams catches people out. If you're asked to describe this cycle, you must give all 3 stages in the correct order. Fetch, then decode, then execute. Skip a stage or list them out of order, and you lose marks, even if everything else you wrote was correct. One more thing that trips people up. Clock speed isn't everything. A CPU with 8 cores running at 3 GHz can actually outperform a single-core CPU running at 5 GHz, especially for multitasking, because modern operating systems are juggling hundreds of tasks at once. More cores means more instructions handled in parallel. Quick check before you go. In the decode stage, what exactly is the control unit doing? Pause here and think it through. Then check your answer and also check it on the LevelUpGh site, where you can try the full interactive quiz for this lesson. See you in Lesson 2.2, where we tackle RAM, ROM, and cache.